So there's different things that you need to know about angles. Like right now, you're pretty familiar with one kind of angle measure, which is degrees. If I ask you how big an angle is, or to represent 90 degrees, you guys are pretty good at knowing what the degrees mean. We know that 90 makes that little corner perpendicular, right? And 180 makes a line. So those are some things that you know about angles in degrees. There's another form of an angle that you need to know, and it's called radians. And so for the first part of what we're looking at today, we're going to be talking about how you change an angle from degrees to radians, and how you change an angle from radians to degrees, and what the difference is. It's basically two types of measure that you can use to describe an angle. And for whatever reason, different people use it in different ways. Just degrees is normally what we're used to, just because that's the most common. So to try to explain just a little bit, I'm going to talk to you real quick about how many degrees there are in a circle and what that has to do with the circumference, to help you understand like how the degrees and radians are related. So, how many degrees are in a circle? 360. If I go all the way around the circle, that makes 360 degrees, and that's important to know. Okay? Next it says, what's the circumference of a circle with radius of 1? So basically it's kind of asking you, if I go all the way around the circle and I think about the circumference, what would it be? Now this is not exactly where radian comes from, but it's a measure to show you what it means. Okay? So, anybody remember what the formula for circumference of a circle is? 2 pi r. Okay? So what does it tell me the radius is? It's 1. So if I plug in a 1 for the radius, the circumference is 2 pi. And so in my mind, one way for you to know how radians and degrees are related is to think about, if I talk about 360 degrees, that goes all the way around the circle. If I talked about the circumference being 2 pi, that goes all the way around the circle. So that's one way for us to describe what I know about 2 pi, and that it's 2 pi is represented by 360 degrees. So normally there's this little XY chart here, and you start over here. 360 is all the way around, so I'm talking about all the way around the circle going 360. And that is represented by 2 pi. Okay? If that's the case, if 360 goes all the way around, and that's represented by 2 pi, what do you think that pi would be represented by? So 360 goes all the way around, and it's 2 pi. So I think that pi would be represented by 180 because it would go halfway around. Because if 2 pi's all the way, pi's got to be half of the way. Good. Alright, what if I wanted to talk about the pi over 2? That's also the same as 1/2 pi. Well, if I know pi goes all the way to 180, how much is half of that going to be? 90, so it comes up here. Alrighty, pi over 4. Well, pi over 2 is this part of a circle. Pi over 4 is basically half of pi over 2. And it's represented by something that looks like this right here. How many degrees do you think that one is? 45. Alright, the next two are a little harder to think about. There's not a good way to describe that one unless I try to draw it all the way around the circle. I do want to just kind of show you real quick. If I was talking about pi over 6, it's an angle that looks kind of like this right here. If I was talking about pi over 3, it's an angle that looks kind of like this right here. And the only way to sort of figure it out is to draw that many of them around the circle and figure it out. But I'm going to tell you that pi over 60 is 30 degrees and pi over 3 is 60 degrees. Now, because you guys are going to future math classes where you're going to use this quite a bit, these are important ones to kind of know. I realize you're going to have your calculator and you can use your calculator in Math 3 when we do this, but these are ones that you kind of just need to know off the top of your head because of things that you might do in future math classes. These two are pretty easy to come up with, and this one's pretty easy to come up with because I can just tell, well, if 180 is pi, and pi, I've got pi over 2, I know that's 90. These three are a little harder to come up with, but as far as just looking at it and knowing it, that's got a 4 in the bottom of it. Pi over 4 has got a 4, so maybe that's 45. Pi over 6 and pi over 3, the 6 and the 3, they're opposites. So pi over 6 is 30. Pi over 3 is 60. That's just a quick way to kind of get it to your mind, maybe what it equals without having to find it. I'm going to show you here in just a second how you can find it and the mathematical way to do that. But sometimes knowing what those are without having to mathematically find it will help you, especially in the future math classes that you might have. Okay? So, the first thing we want to do is we want to convert from degrees to radians. And we kind of, that was just our introduction to talk about what it looks like. There's a rule here and it says multiply by pi over 180, and I'll show you how that works. But I want to show you another way first, just because I think that if you are in future math classes and knowing what it is just right off the top of your head, this might be another way to do it. So 120 is a multiple of something up here. What is it a multiple of? Either 30 or 60, right? How many 60s make 120? 2 of them. So I could say that 120 is 2 times 60. Well, if I know that 60 is pi over 3, then I would know that this is 2 times pi over 3. And there's another way to write it, 2 pi over 3. If you know it's a multiple of something else, then you can figure out how many of that you need and then put it together to change it to radians. I really like it that way, just especially if you have to do it fast. I'll come back in a minute and I'll show you what this means by multiply by pi over 180. But let's just do it this way first. Alright, so we have 240. So is 240 a multiple of something else? Is there something I can multiply up here by to get 240? 60 times 4? Or 4 60s? Again, I know that 60 is pi over 3. So this would be 4 pi over 3. You could use 30 as your multiple, but if you use 30 in these two cases, you will have to reduce it. That's okay. It's fine. You just got to be able to do that. Now, number 3 is one that you just might not be as familiar with as others. I'm going to tell you because that 5's on the end, it's probably related to a 45 degrees. So 45 is right here. And then if I go 45 more, I get to 90. If I go 45 more, I get 135. 45 more is 180. And 45 more is 225. It's not something that I just know how many 45s make 225, but I kind of can know where it is on my graph. So how many 45s make 225? 5 of them? And then 45, according to up above, is pi over 4. So that's 5 pi over 4. Try the 480 one very quickly. So 480, how many of something is it? So 6 times 8 does give me 480, but where is the 0 going to be? It's got to be with the 60, because 60 is what we know. We don't know 80. We know 60, and there's 8 of them. 60 is pi over 3, so it's going to be 8 pi over 3. Now, my rule actually says multiply by pi over 180. Okay? Let me show you what that means as far as what I think that would mean in the calculator, because I'm going to show you in just a second, it's not always just special ones. So like if I had 120 and I wanted to multiply by pi over 180, pi is here where the little up button is. Notice that that answer is a really strange answer. Now, if I put in 2 pi over 3, I'm going to get that answer. But that's not how we need to write it. We need to write it with the pi's, with the radians. Okay? So what I would recommend, if you decide that you don't want to do it the way I just showed you, if you'd rather multiply by pi over 180, do 120 divided by 180. Change it to a fraction. Math, fraction, enter. And then put the pi with it. Okay? So that's 2/3, and then put the pi with it. If I were going to do 240, it would be 240 divided by 180, change it to a fraction, 4/3, and then put the pi with it. So don't just put in pi over 180, divide by 180, and then put the pi with it. The reason that's important is because what if, and I'm just going to have another example here, example 4.5, 132 degrees. See, 132 degrees is not a multiple of 60, 30, or 45. Okay? So there's something different I have to do with 132. Alright? So I'm going to do it kind of what I just showed you. I'm going to do 132 divided by 180. Change it to a fraction. So I got 11 over 15. And then I'm going to put the pi with it. So 11 pi over 15. Questions about that? So this one says multiply by 180 over pi. So it's the opposite of that right there. I actually think it's easier to do it a different way, and I want to show you that. I know there's a couple ways to do it. I know what 180 represents. I know that pi represents 180, right? So what I could do is I could say 2 times 180 and divide by 3. Kind of just replace the pi with the 180, because I know that's what it represents. And you get 120. You can do it that way. Or you could think about, okay, I know that pi over 3 is 60. And so that would be 2 times 60, which is 120. And I know that's the same thing as that right there, but I need to show you how to change it because you won't always just have it on your paper. Questions about that one? So you can either just plug in the 180 for the pi, or if you know what pi over something is, you could replace that whole thing with it and then multiply it by the number. Okay? Look at the next one. 13 pi over 6. So that could be the same as 13 times 180 divided by 6, which comes out to be 390. The other way I could do it is I could figure out, okay, pi over 6 is how much? 30. I could say that this is 13 times 30, which also is 390. I like the second way just because I don't have to use a calculator quite so much. But if you like the first way, that's fine too. Try number 7 and 8. So on number 7, we can either say 5 times 180 divided by 2 and get 450. Or we can say 5 times 90, which is also 450. So either one of those will give us the correct answer on that one. Now, number 8's a weird one because you do get a decimal on that one. This isn't a special one because it's pi over 7. There's not pi over 3 or 6 or 4. So we do have to just plug a 180 sort of in for pi. And when we do that, we get 77.4. Questions about that? Okay, so the first part that you need to know about angles is you need to be able to change it from radians to degrees. You need to know that there is a difference between the two and be able to change it. The next thing you need to be able to do is to be able to graph it and find what's called the reference angle. Okay? So, let's talk about graphing it first. And we've sort of been graphing a little bit, but we're going to talk about some more. So, with graphing an angle, you always start on the positive x-axis. That means you always start on the x-axis on the positive side. Every time. Now, you're going to have positive angles and you're going to have negative angles. Okay? When in terms of a triangle, your triangles will always be positive, but negatives are represented for a different reason. So, if an angle is positive, the direction is counterclockwise. I'm going to show you what that means. I'll just go ahead and give you the words. If the angle is negative, the direction is clockwise. So, you're going to start here, no matter what angle it is, you start over here. If it's positive and it wants us to draw it, you're going to start here and you're going to come around this way. And the reason that's counterclockwise is because if you think about a clock, the numbers are going this way, the hands are going this way. So that's clockwise if you go that way, but counterclockwise if you go the opposite direction from the clock. And that's the opposite direction from the clock, but that's positive. Okay? If it was negative, the negative is clockwise, so you still start over here, but you go down in this direction, and that would mean if it's a negative angle. I also have this here to tell you where the quadrants are, because sometimes a question might say, find the quadrant that the angle lies in. If it lies in this quadrant, it's quadrant 1. If it lies here, it's quadrant 2, 3, and 4. So the quadrants are based on the fact that if it's positive, it comes around this way, and that's the direction that the quadrants fall in. Okay? If you ever hear, where does the terminal angle fall? It means, what quadrant does it fall in when you find it? Okay? The last thing that it tells me is about the reference angle, and that's what we're going to be looking for as we graph these angles, is we're going to be looking for the reference angle. The reference angle is the angle that you form with the x-axis. Okay? You don't have to draw this down, but I just want to show you real quick. If you have an angle that starts over here and ends here, what you're going to do is you're going to make a line, coming from 0, 0. That shows you what the angle looks like. And then you're going to make a triangle with the x-axis. Okay? When you make the triangle, you never go across with the triangle. You always go up or down. And the reference angle is the angle in the triangle with the x-axis. This angle right there is the reference angle that's asking for. Okay? If the angle fell in this quadrant, and you draw your little line, you still draw a triangle, and the angle it's asking you for is the angle in that triangle. Notice in this triangle, it was like what was left over to get to the next line. This one was how much it went over after that line. It's not always just the gap. It's the part with the x-axis. Okay? If the angle fell in this quadrant, and I make the triangle, it's that part right there. So it's always that angle with the x-axis when you make that triangle. That's what's called the reference angle. So all three of those are the reference angles that we'll be looking for. Okay? And when you try to figure it out, you're going to probably be subtracting or adding something to figure it out. If you know what this angle is, and I need to know how much more I go to get to here, it's kind of like I'm subtracting this angle from 180. In this problem, I need to know how much more I went past 180, but it's still this angle minus 180. In this one, I need to know how much more I go to get to 360, so it's this angle minus 360. So usually you're just subtracting, but you're subtracting like angle and then whatever the next little part is on the line. Okay? Alright, let's look at that. Let's see how that matters whenever we do some problems. So let's look at number 9. Number 9 says 250 degrees. So what we're going to do first is we're going to draw 250 degrees. Alright, it's positive, so it's going to start here and go around this way. I know that if I just go to here, how much do I go? 90. Alright, if I go to here, how much is that? 180. If I kept going and go all the way to this line right here, how much would that be? 270, because it's another 90. I want to go 250, so I don't want to quite go to the line. So I want to go maybe to about right there. That's how you graph the angle. That's the angle. If I say graph it, that's how you do it. Now, what I need to do next is I need to make the triangle with the x-axis. So here's my triangle. And what I'm looking for is this angle right here. My reference angle is that angle right there. Okay? If you think about where you are and where you came from, usually you just subtract those two things. So I'm going to take 250 and I'm going to subtract 180. Or think about how much more than 180 did I need to go to get to 250. Okay? So 250 minus 180 is 70, and then 70 is my reference angle. Questions about number 9? I'm going to scoot down to 13, and then we'll come back to the other one in just a second. So 13 says 390. Alright? So 390 is above 360. You probably never knew you could have an angle above 360. It just means it keeps going. So it's positive still, so it's going to start here. Let's go all the way around to 360, and then a little bit more. And then I'm going to draw my angle, and then I'm going to draw my triangle. The reference angle I'm looking for is this angle right here. So this is the 360, and that's the 390, so what two things do you think we're going to subtract to figure out the reference angle? 390 and 360? Because that's the two that we were at. You could also just think about it and think, how much more after 360 did I need to go? Well, I needed to go 30 more, so 30 is my reference angle. Okay, when you find negative 320, first of all, it's negative, so it's going to come around this way. I know it's past 270, so it's this part right here. There's my angle. Okay, make a triangle. The angle that we're looking for is this angle right here. And in that case, it's like, how much more do you take to get to 360 from 320? Or, if you think about the triangle, this is 360, that's 320. So we're subtracting 360 and 320 to get 40. Those of you that got 50, you got this angle up here, which is not the reference angle because that's not in the triangle that I'm looking at. Alright, look at number 14. Negative 370. So, negative means I got to go all the way around. So I'm going to go all the way around to 360, and then I'm going to go a little bit more. Okay? There's where the angle's going to end, and then there's my triangle that I need. So for my reference angle, I'm just looking for this little angle right here. It's how much past 360 I need to go to get to 370, pretty much. So I can do 370 minus 360. And it's 10. Number 11. 5 pi over 6 comes out to be 150. So we're going to draw where 150 is. Part of the thing is to draw the angle. Then you make your little triangle. Your angle you're looking for is this angle down here. That's 150. That's 180. So you're subtracting 180 and 150. So 30 is your reference angle. Number 15. If you change number 15, you get 480. And so basically to draw or graph 480, you go 480, which is 360. And then you go 120 more. And 120 comes out to be kind of that same quadrant that we have right there. Make your little triangle. I'm looking for this angle down here. Some of you wanted to subtract like 480 minus something. You can't do it that way because 480 was more than 360. Think about how much extra you went from the 360. We actually went 360 and then we went 120. So 120 is where I am right now. So I'm going to take 120 minus 180 and get 60 for my reference angle. Number 12. First of all, that's going to be negative 120 when you change it to degrees. Same. Negative 120 starts here and goes around this way. Okay? We make our triangle with the x-axis, so we're looking for this angle right here. That's 120. That's 180. Subtract that, our reference angle comes out to be 60. Lastly, this one right here is negative 630. The way that I would think of that one is 790s. And it's negative, so it's going to come this way. So there's 1, 2, 3, 4, 5, 6, 7. That's kind of how I would draw it. That's because it's 790s. That one does not fall in a quadrant. It falls on the line. It falls on the axis. When it falls on the axis, there's no reference angle. It just falls on the axis, and that means something else. Okay? Is being able to determine the angle whenever it's drawn. Okay? So number 17, if I want to figure out what angle that is, I'm going to start here and go around. Is it positive or negative? Positive, because I went up and around. I know that I went 3 90s, so you can do 3 times 90. Or you can just know that that was 270. Alright, number 18. I know that this is negative because it started here and it's going around this way. So I know it's negative. Alright, I know that from here to here is 180. And then I had to go 90 more. So I know that that's 270. And then a little bit more. Do you agree? So that's 270 and 20 more. So we get negative 290. Alright, number 19 looks really weird. And I'm going to do it in pieces. Okay? So start in the center. Is it going to be positive or negative? Positive. So one circle is 360. Okay, and then I'm going to go another circle. So there's another 360. I'm not going to go another full circle, but I go another 180. And then I got to go a little bit more. How am I going to figure out that little bit more? So I can see that this part's 75, but I know this whole part from here to here is 90. So I'm going to do 90 minus 75 and get 15 for that little bitty part. So then I'll add 15 to that. And I get 915. So you should get 325, 500, negative 475, and 345 for those answers. Anybody need me to do any of them? Alrighty. So some other things that you need to know about trig are some things that you've probably already learned. You did some trig in Math 2. And I want to remind you of some of the things that you learned in Math 2 about trig. And we're going to use some of that. And then eventually what's going to happen is we're going to put all these things together. These things we know about the angles and these things that we know about the sides that you're going to learn about and talk about today. We're going to put all that together to solve some things. So what I want to remind you of, first of all, is SOHCAHTOA. I think that most of you have used that before. It's sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And I'm going to explain all of that, but I think you've heard at least that strange word before. So, let's say that we're talking about this triangle right here, and angle P is our starting angle. Okay? We're going to first label the triangle. Okay? We're starting with angle P. So here's angle P. So where's the opposite side of angle P? Opposite, over there. After I label the opposite side, I usually label the hypotenuse. The hypotenuse is across from the 90. So if this is the 90, this is the hypotenuse. And the other side is the adjacent side. Adjacent is just the extra side there that's not opposite. Okay? So, the opposite leg to angle P is QR. The adjacent leg to angle P is PR. And the hypotenuse is QP or PQ, whichever way you want to write it. So, try the same thing with angle Q. Figure out what the opposite, adjacent, and hypotenuse is for angle Q. So, if you start with angle P, and if you start with angle Q, the sides do change a bit. The hypotenuse is still the same. But the opposite is no longer this side right here. It's the side here because that's opposite from Q. And then the adjacent is this side here. So opposite leg to angle Q would be PR. The adjacent leg is QR. And the hypotenuse is QP. Alright, let's look at this triangle, and here's a bunch of words. So, sine, cosine, and tangent are the trig ratios that we're going to be talking about. Here's the abbreviation for them. And here's the definition. The opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay? So if I have this problem right here, and I'm interested in A, it tells me I'm interested in A. We're going to start with A. Opposite is across from the A, so that's the O. Across from the 90 is the H, and then the other side's the A. So opposite to angle P, oh, we're still talking about A, sorry. Sine of A, opposite over hypotenuse, is 3 over 5. Cosine of A is adjacent over hypotenuse, which is 4 over 5. Tangent is opposite over adjacent, which is 3 over 4. And we'll be working some more with that later. You may or may not have learned in other math classes that there's 3 other trig functions. There's sine, cosine, and tangent. But there's also cosecant, secant, and cotangent. Okay? These are the reciprocals of sine, cosine, and tangent. For example, if I ask you a question about cosecant, what you do is you find sine, and then you do the reciprocal of it, or flip it. So if sine is 3/5, cosecant is 5/3. Cosine and secant are reciprocals of each other. So if cosine is 4/5, secant is 5/4. Tangent and cotangent are reciprocals of each other. And so if tangent is 3/4, cotangent is 4/3. And the way that I remember which one goes with each other are their opposites. Like, look, sine starts with the S, cosecant starts with the C. Cosine starts with the C, secant starts with the S. Tangent and cotangent, you just got to remember that. You got to remember that COT stands for cotangent, and so that's got to be the reciprocal of tangent. We won't have to do a lot with this, but in future math classes you will. And so I think it's important for you to know that there are actually 6 trig functions. And These three are not on the calculator, but to find them, you have to know that they're a reciprocal of sine, cosine, and tangent. Okay? Now, the last thing that we'll talk about today, we want to be able to find all the trig functions all the time. But the problem is, if I look like at number 1, and let's say that I wanted to find sine of angle P, or B. Sine is opposite over hypotenuse. Opposite's 15, what's the hypotenuse? I don't know. So this is where we need to use the Pythagorean Theorem. I want to remind you what the Pythagorean Theorem is so that we can find the other side, so that after we find the other side, then we can find all the trig functions that we need. Okay? You can only use Pythagorean Theorem when you have right triangles. If they are not right triangles, you can't use Pythagorean Theorem. All of these are right, so that's really nice. What we want to do first on number 1 is figure out which sides are our legs and which is our hypotenuse. Remember that A and B are the legs, C is the hypotenuse. So it doesn't matter which one you let the legs be as long as you have C correctly. Okay? So in this problem you would say, okay, that's 8 squared plus 15 squared equals C squared. And so to solve that, I'm just going to put 8 squared plus 15 squared in the calculator. And then I'm going to take the square root of that. Questions about number 1? Alright, number 2. Again, it doesn't matter the A and the B as long as you have the C correct. So I'm going to have x squared plus 15 squared equals 21 squared. On this one we had to add because we had both of the legs. We don't add here. What do? Subtract, because I want to subtract over that 15 squared. So I'm going to do 21 squared minus 15 squared. And then what am I going to do to find x? Square root. Questions about that?